Now in this section, we're going to look at some equations that involve some fractions. Let's look at our first example. We have 2 over x plus 4 over x equals 3 minus 1 over x minus 17 over 8. Now, because we have fractions and we're going to have to do a little check at the end of our work, we're going to take the extra 10 seconds or so it takes to rewrite that original equation so that at the end we will be able to check to make sure that our answer makes sense. So notice here's the original equation. I just copied it exactly as is right underneath. Now, rational expressions, of course, is anything that has a fraction. So here we have an equation, an equal sign, with some fractions. Now, we have to be very careful because in the last chapter you dealt with rational expressions. And because you had expressions, you could only multiply expressions by any form of the number 1 to change the form of the number, but not the value. That's very different from what we're doing here in this chapter. In this chapter, in this section I should say, we have rational equations. We know that with the equations we can do whatever we want as long as we do it to both sides of the equation. So if, for instance, we choose to multiply both sides of the equation by 8, we can because we have an equation. If it was an expression, if this wasn't here, we would always have to multiply by a form of the number 1. So if we wanted to multiply by 8 to change the form and it was just an expression, it would have to be 8 over 8, which is equivalent to 1. So keep that in mind as you work through this chapter. All right, so in this section, again, we have these rational equations. We can multiply both sides of the equation by anything that we choose, as long as we do it to both sides. So what we're going to do to eliminate our fractions, and I know you've seen this procedure before, is to multiply both sides of the equation by the LCD. In this case, look at all the denominators. The LCD is pretty easily found. It happens to be 8x. So LCD, we'll write it right here. LCD happens to be 8x. Now what we're going to do at this point is multiply both sides of my equation by my LCD to clear the fractions. Now what I'm going to do is write this times 8x by each of my terms just to make it a little easier in my calculations. So there it is, LCD 8x. I multiply my first term by 8x. The x's divide out. I'm left with 2 times 8, or 16. Plus, multiply the second 2. My x's divide out. I'm left with 4 times 8, or 32. Equals, on the right-hand side of my equation, I have 3 times 8, or 24x, minus the x divide out here. I have 1 times 8, which is 8. And finally, on the end, the 8's divide out, and I have 17x. And notice that's a negative sign there. Don't forget the negatives. Okay, now that I've done that, notice the original equation, which involved all those fractions, has been simplified greatly all the way down to here. We have no more fractions. So we'll return to the procedures we learned for solving simple equations. Let's combine like terms. We have 16 plus 32 on the left-hand side, which gives me 48. Equals, on the right-hand side, I see I have 24x minus 17x. That gives me 7x. And then I have a minus 8 there. Now again, I'm solving for x. So I'm going to add 8 to both sides of my equation. That gives me 56 equals 7x. Finally, divide both sides of my equation by 7, and x is equal to 8. Now remember, what we said originally, the reason why we took the trouble of rewriting the equation was because we wanted to have our original equation left to reference it. And so now let's check. And what you're checking for is when you get your value for x, you want to make sure that no denominator has a value of 0. Because we know that 0 in the denominator means an undefined fraction. 8, 8, 8. Sounds like we're good. so we're okay. Again, the original equation here was left, so at the very end we can check to make sure that no denominator becomes 0. That wasn't too bad, was it? Are you ready to try a little bit more challenging problem? Let's try that now. Again, these are equations, so that gives us the freedom to multiply both sides of the equation by anything we choose. Now we'll start with this second rational equation. We've got x minus 1 over x squared minus 4 equals 2 over x plus 2 plus 4 over x minus 2. So here again we have a rational equation. What we want to do is multiply by the LCD to clear those fractions. Well, in this particular problem, we have one little problem, one big problem, and that is this: not all the denominators are in factored form. So our first step here before we can clear our fractions is in determining the LCD, factor all denominators. Let's go ahead and just to save ourselves a little space, let's just factor this denominator right here as x plus 2, x minus 2. I'm sure you all recognize that this is the sum, this is the difference of perfect squares, so it simply factors into x plus 2x minus 2. When I compare this denominator, which I factored, to the other two that were originally there, I hope you can easily see that the LCD is x plus 2, x minus 2. Now again, as we did in the previous problem, just because what we want to do is have that original equation there to reference, what I'm going to do is now rewrite the original equation with our factored denominator. So we have x minus 1 over x plus 2, x minus 2, the factored form, equals 2 over x plus 2, plus 4 over x minus 2. Notice nothing has changed on the right-hand side of the equation. Now, we just said that this happens to be my LCD, so the next step is we're going to multiply each of these terms by that LCD to clear the fractions. So what I'm going to do here is just write each of these terms. I'm going to write my LCD right next to my terms, so it'll be easier to calculate as we did in the previous problem. X plus 2, x minus 2, and I know it gets a little crowded, so just write as neatly as possible there. X plus 2x minus 2, x plus 2x minus 2, and x plus 2, x minus 2. So what am I doing here? I'm taking this equation. Let me just erase this extra x minus 2 because we don't really need it at this time. That was just the factorization of that first denominator. So what we're going to do here is we're multiplying both sides of my equation by the LCD that we found, which is x plus 2, x minus 2. Now, what we're going to do is multiply so we can divide out common factors. The x plus 2's divide out. The x minus 2's divide out. And what am I left with? On the left-hand side, all I'm left with is x minus 1. Let's continue on the right-hand side. On the right-hand side, now what I'd like to do is put these denominators in parentheses, because that reminds me that if the x and the 2 cannot divide out separately, they have to go as a pair. So either both of these go together or they both stay. So x plus 2, I see I have an x plus 2 in the numerator. So I'm going to multiply, and I'm going to divide out those factors, and I'm left here with 2 times x minus 2. Also, moving right down, doing the same procedure here, I've got plus, and again, I'm going to divide out common factors. I see the x minus 2. I'll divide out with this one here. So what am I left with? I'm left with 4 times x plus 2. Now, I know you agree that this line here is much simpler than the original equation, which had lots of fractions. So now our job is just to simplify this or solve for x in this equation. So let's go ahead and rewrite the left-hand side because there's nothing to simplify there. On the right-hand side, I see that I have to apply the distributive property twice. So that gives me here 2x minus 4, using the distributive property here, and then one more time down at the end, which is 4x plus 8. It's almost relaxing once we get to this point, wouldn't you agree? Now, at this point, we must collect like terms on each side. We have x minus 1 equals, collect like terms. I've got a 2x and a 4x, 2x plus 4x. That gives me a 6x. And finally, negative 4 and positive 8 is positive 4. We're almost there. Now, I want to solve for x. Let's see. You can go either way. You can bring the 6x to the left-hand side or bring the x to the right-hand side. It's up to you. I usually like to leave the x in positive, so I'm going to bring this x to the right-hand side by subtracting x from both sides of my equation. That leaves me negative 1 equals 5x plus 4. We're almost there. Then I have to isolate the 5x by subtracting 4 from both sides. Negative 1 and negative 4 give me negative 5 equals 5x. And we're almost there. I think we can easily see that to solve this equation, we need to divide both sides by positive 5. When we do, remember that negative 5 divided by positive 5 is going to give me a negative 1. And there you have it. Now again, don't be too anxious. You must go back and check to make sure that your solution does not give you an undefined fraction in your original equation. So let's take the negative 1, go back up to my original equation. If I substitute in my denominator here, negative 1 for x, that gives me negative 1 squared or positive 1. Positive 1 minus 4 is negative 3. That's not equal to 0, so we're okay. Negative 1 plus 2 is positive 1. We're okay. Negative 1 minus 2 is negative 3, and that's neither 0 as well. So this solution is valid for this equation, and after all this work, be careful, x is equal to negative 1.